So we are doing the Euler number investigation. Now we've talked about the fact that exponential functions have derivatives that basically are exponential functions. What we want to do here is we want to test the conjecture that somewhere out there there's an exponential function that is its own derivative. Okay. So we're going to do an investigation, and we're going to experiment with different bases. When you open this, you're going to be starting with a base of 2. So this is our function is 2 to the exponent x. We are going to investigate the slope of this function at different values of x. You'll notice that the tangent has been produced. Right now x is negative 3. And I can see that the slope of the function when x is negative 3 is 0.0866433. Anyways, I am going to fill that in down here in this table. The table will plot points, and we will see if those points, which essentially make up the slope function, happen to be on the function itself. Now, to really find this out, what you can do is you can zoom right in, and I can already see that when my base is 2, this point isn't lining up. It's not on the function, and so the slope function is not the same as the function itself. So this exponential function does not appear to be its own derivative when the base is 2. Now, you should maybe test that. You'll see as you go with bigger and bigger values of x, this might get a little more exaggerated, or it's possible that we made a rounding error here. So I encourage you to continue to investigate a base of 2. When you're done investigating a base of 2, which, as you've probably guessed, no, that's not the base, that's its own derivative. Otherwise, I wouldn't have started there. I want you to change the base. So you might say, well, I can see that the slope there was a little bit inadequate, so I'm gonna really give it a better slope by increasing that base to 3. And you will just have to replace the values in this table. And so, for example, I can see that when x is negative 1, or sorry, let's just go to x is negative 3. I can see that the slope is 0.04100, etc. Anyways, I would replace that in the table and see what happens with the points. You might want to try bigger values of x to get the idea right away. What you are trying to do is find what base makes an exponential function that is its own derivative.